Hello and welcome to a video on solving rational inequalities and some polynomial inequalities. So the first one we're looking at is a rational inequality. You have to be really careful with this one. Now the first thing you definitely want to do is you want to make it, you want to get the zero isolated. So I'm going to rewrite this as x plus 8 over x minus 6 less than or equal to 0. Now what you don't want to do is you don't want to just multiply everything by x and say I don't even have a rational function, because you don't know what x is and it may be 0. So instead of doing that, we're going to get a common denominator. So I'm going to rewrite this as 8 over x plus x minus 6, and I'm going to multiply that by x over x. So this thing right here by x over x, which is just 1 no matter what, unless x is 0. But we're going to keep that x in the denominator, so we don't have to worry about the 0. We're going to keep that in mind. We know that x can't be 0, so we're not just going to ignore that. And then that's less than or equal to 0. So we distribute, and we get the 8 over here, and then we get an x squared minus 6x. And the important thing to keep is that it's all over x, and don't ignore that denominator. So now we're going to be able to factor and see our 3 critical points here. So when we factor this, let me put it in order first. X squared minus 6x plus 8 over x less than or equal to 0. Now let's factor, and we get x minus 4 times x minus 2 over x is less than or equal to 0. Okay, now we're ready to start thinking about our critical points and analyzing this as a rational function. We'll get a number line, we'll do a sign chart, and all that fun stuff. All right, so our critical points are going to be what makes the zeros. So it's going to be 4 and 2. And then these are the zeros. And then also the whatever's undefined. So the exclusions from the domain. And that's going to be 0. So we can set up a number line, and we're going to plot these 3 points in order, so 0, 2, and 4. And this is a number line continuing towards positive infinity and continuing this way towards negative infinity. So we're looking at a total of 1, 2, 3, 4 intervals. And we have to examine each interval separately. Okay, so let's pick a test point of -1 here. Now when I plug in -1 over here, I'm going to get a negative times a negative over a negative, right? Negative times a negative over a negative, and that is a positive over a negative. It's going to be a positive result. When I plug in over here, I'll test the number +1. That would be a good test point between 0 and 2. When I plug that in over here, I get a +1. I'm going to put a negative. I put a +1 here. I get a -3. So that's a negative times a negative over a positive. Negative times a negative over a positive this time is a positive over a positive. And that's a positive. What did I say over here? This is a positive over a negative. I think I said negative, but I wrote positive. So this is supposed to be a negative over here. All right, let's keep going. Let's pick 3. That's a good number between 2 and 4, so we'll pick +3. And when I put a +3 in here, I get a negative times a positive, negative times a positive over +3, which is positive. So that's a negative over a positive, that's a negative. And we have one more, and we'll pick +5 as our test point for this last interval. And when I put +5 here, I get positive, positive, positive. All of them are positive. So that's definitely positive. Now let's just think a little bit about where we're starting here. Our undefined, that's going to have to always be an open circle. So that's going to be an open point here. So let me just plot that open point here. And the 4 and the 2 depend on this. Now this time it's including 0, so those are going to be parts of the solution. So I'm going to make those closed points at the 4 and the 2. Now the intervals that I want are the ones that are less than, so I want the negative interval. So I'm going to keep this interval here, I'm going to keep this interval here, and then the endpoints. So my final answer would be negative infinity to 0, not including 0. and then it would be from 2 to 4, including both endpoints. And that's it. Okay, let's take a quick look at this graphically. Now there's a couple ways to look at this graphically. You could graph it. I'm going to show you what the graph looks like, and we're just going to kind of go from there. So let's take a quick look at the graph. Now here's the function on Desmos, and as you can see, up to 0, the value of the outputs are all down here in this branch to the left of 0, and so they're all negative. Between 0 and 2, now this point right here is 2. Look at the scaling. It's not 1, but this right here is 2, and then between 2 and 4, or from 0 to 2 it's positive, and then from 2 to 4 it's negative, and then from 4 to infinity it's positive again. So our only intervals where it's positive, greater than or equal to 0 in this case, 0 to 2, not including 0 but including 2, and then from 4 to infinity, including 4, of course not including infinity. Now just a couple things I want to show you. Another way to look at this is to look at the left side and the right side. Now you can see the ones that I just darkened here. Let me just move this over so you can see which ones are actually being graphed. So I'm graphing in blue is the graph of the left side of the inequality, the original inequality that we had. In green is the right side. And so you can do the same thing. You can say, where is the blue curve above or equal to the line? And that also, you can see that that happens from 0 to 4, and then, from 0 to 2 here, and then again from 4 to infinity. Just a word of caution, I told you don't multiply everything by x, right? So what would happen if we did multiply everything by x? We get a completely different function, and this function is not positive in only the same places. It's also positive here in the negative area, and we don't want that. Okay, so that would be a mistake. All right, I hope you found that example helpful. Let me pause it. Okay, and we're going to do one more example, and this one is something that we've seen a lot of, but we're just going to throw it in here because it makes sense in this unit. And so we're looking at a radical now. Now this is not a rational function or a polynomial function because it has a radical. But we're not asked for that. We're asked for the domain. And remember that the domain is whatever makes the radicand greater than or equal to 0. The radicand is a polynomial function. So this is 9x squared minus 4 would have to be greater than or equal to 0. So to answer that question, we've been doing this all along, you need to solve a polynomial inequality. So we're going to look at the critical points. Since it's a polynomial, they're just the zeros. And so we can factor this. It's a difference of squares. 3x plus 2 times 3x minus 2 is greater than or equal to 0. And just another reminder of what not to do. Don't do this. Don't say, therefore, 3x plus 2 is greater than or equal to 0, and 3x minus 2 is greater than or equal to 0. That, again, is a big don't do that, please. All right, what we want to do is we want to analyze each of the zeros separately on a number line. So we're going to make the number line. We're going to put the 0 for the first one, 3x plus 2. We're just going to find the 0, so just as an equation. And that's going to give us negative 2/3. I'm going to move my number line down a little bit so I have a little bit more room to work. All right, and then this one would give us x equals positive 2/3. And those are our only critical points. So we're going to put them on our graph. Negative 2/3, positive 2/3. We're looking to include the points that are equal to 0, so these are both going to be darkened. These are both going to be part of the solution, whatever else happens. And we're forming 3 intervals. Now this goes to negative infinity, and this goes to positive infinity. And we just have to decide which intervals are going to be solutions to the inequality. So we're going to pick one value in the far left interval, and I'm going to pick something less than negative 2/3. How about negative 1? All right, if I pick negative 1, and I plug it in here, and I get negative 3 plus 2, that's a negative. And then negative 3 minus 2 is also a negative. So everything in this interval is going to give me a positive output. Then I'm going to pick 0 in between here as my test point. So 0, that's a good value between negative 2/3 and 2/3. And if you plug 0 in here, same place in both of these, you're just going to get 2 times negative 2. It's going to be a positive times a negative, which means it's going to be negative. And then if we pick a test point that's beyond 2/3, how about 1? And we plug that again into the same place, we're going to get 3 times 1 plus 2, which is a positive, and 3 times 1 minus 2, which is a positive. So we're going to get a positive output. All right, now again, what we're looking for is we're looking for the positive outputs, anything greater than or equal to 0. So our final intervals will be, we'll just go from here to here, and then continuing in that direction, and then from here to here, and continue to infinity. So it would be negative infinity to negative 2/3. Inclusive, and then union with positive 2/3 to infinity. And there we go. Okay, I hope you found this video helpful.